measures of location and spread using coded data. So why do we code data? It could be to make the numbers easier to work with. For instance, I've got some data here on air pressure measured in hectopascals. So to make the numbers easier to work with, I could subtract 1000 from each of these data values. So this is my coding here. You will be given a coding formula. So I can replace the a minus 1000 here with y. So we have the original data in blue, and I've got my coded data in red. And using the coded data, we could work out any measure of location. So that could be one of your averages, the mean, median or mode, or things like your quartiles or percentiles. You could work out any measure of spread, so range, interquartile range, standard deviation or interpercentile range. And you're doing all of these calculations on the coded data, and they should be easier than doing the same calculations on the original data, because the numbers are easier to work with. And then finally, you undo the coding to work out your measures of location and spread for the original data. Coding can be useful when we convert units. This formula converts temperature from degrees Celsius to degrees Fahrenheit. And this formula gives the conversion from degrees Fahrenheit to degrees Celsius. This table gives the average monthly temperature in Fahrenheit for 10 cities for a year. We've done calculations on this data for measures of location and spread. So everything so far is in Fahrenheit. Now we also want all of these measures in terms of degrees Celsius. So we need to use the coding formula to convert from Fahrenheit to Celsius. We use coding when standardizing in a normal distribution. So here we have x, which is any normal variable with any mean and variance, and we've coded using this formula to the standard normal variable z, which has a mean of 0, variance of 1 and standard deviation of 1. And this is helpful especially when calculating unknown means or standard deviations. We need to understand the effect of coding on measures of location and the measures of spread. And what we'll see is that the effect of coding on any of these measures of location is exactly the same, and the effect of coding on any measure of spread, so irrespective of which one we're dealing with, is also the same. In this example we have 3 data values. This is the original data. I have a measure of location, I'm going to use the mean, and a measure of spread, I'm using the range. So the mean of these numbers is 11, and the range, the highest value minus the lowest one, is 2. Now I'm going to code the data by adding 2 to all of the original data values. So the new data is x plus 2. Here are the coded data values. We have to work out the mean and spread for our coded data next, which is 13 and 2. So without having to modify the data first and then work out the mean and range, is there any way we can get from the mean and range of the original data directly to the mean and range for the coded data? And it's fairly straightforward for this example. For the mean we just add on 2, we're doing the same as here. For the range we can see there's no change, so adding a fixed amount to all of your original data has no effect on the spread. Location changes by the same amount. In this example I'm subtracting 5 from all of my original data to get these coded values. I've got the original data's mean and range, coded data's mean and range, and this time we can see the effect for the mean is to subtract 5, and for the range again there's no change. The effect of subtracting a fixed amount to all of your original data has the same effect on location, but on spread it has no effect. And this time we're multiplying all of our original data by 2, hence the 2x. So coded data coded mean, coded range, and the effect this time is the same on both the mean and the range. So if you multiply all of your original data by a fixed amount, then both the location and spread also change by the same multiplier. So the effect of dividing all of your original data by the same amount, so here's the coded data represented by x divided by 10, and I've got my coded mean and the coded range. So we see that both the mean and range are also divided by 10. So if you divide all of your original data by the same value, then both the location and spread are also divided by the same value. Now we're coding the data by multiplying all of the original data by 3, and then we're subtracting 2. So for example, 10 times 3 is 30, minus 2 gives us 28. So the original data represented by x multiplied by 3, so that's 3x minus 2. So here's the coding. Coded data, coded mean, coded range. So for the mean, we're doing exactly the same as this, as the coding here. We're multiplying by 3 and subtracting 2. So 11 times 3 minus 2 gives us 31. But for the range it's not the same. Only the multiplying part has an effect. So 2 times the 3 gives us 6. The subtracting part had no effect here. So now we summarize our findings, and we find that if we add or subtract a fixed amount to the original data, the location value changes by the same amount, but this has no effect on any measure of spread. And if we multiply or divide all of our original data by a certain value, the effect on the location and the spread is exactly the same.